Yes, all right, thank you. As Renan said, my name is Jeff Bonkowski. I was a career firefighter in the Detroit area, small community called Trenton, Michigan. We had a lot of heavy industry and bars, auto industry, chemical plants, steel mills. And within that, I, through my career, trained to the level of a hazmat specialist. I was a paramedic, and I ran a 17 community mutual aid hazmat team, as well as a regional hazmat team within the state of Michigan. So through my career, I tried to learn as much about some of the high hazard fires as possible that we deal with. And so I apologize. So through that, we tried to learn and see what I could do about finding a solution, because many times when I would do my trainings, chiefs would ask me how I would deal with some of the high hazard fires I was doing the trainings for. And in many cases, I would often ask or tell them that let it burn, protect your exposures, let it burn, that they did not have what they needed to be able to extinguish those types of fires. So with that, I began a quest to see, thinking, hey, 21st century, there has to be something out here that could be more effective and be able to help fire departments and basically industry be able to deal with the high hazard fires that they're faced with. So my quest led me to Hazard Control Technologies, and what we're going to learn about here is the encapsulator agent, and now how it can work in deluge systems and in fire protection systems. So just to cover some of the hazards and some of the things that we talk about with the agent, we start off here showing I'm showing this tank farm fire that is burning.
And about 12 hours ago, and it's only getting bigger. Stephanie.
And I stop it there because, they're talking about, hey, here this fire started 12 hours ago and it's only getting bigger. And when I sit there and I go back and we start there and start looking, you'll see that there's a number of tanks within this farm. And when we sit there, we go to the next slide, we'll see that this fire started at a manifold. It started as a three-dimensional fire, and the current technologies and the current things that we're using are very ineffective at being able to deal with these three-dimensional fires. And if we even go into the NFPA 11 foam standard, it's going to state in the standard that foams are not suitable for three-dimensional spraying, flowing liquid fuel fires or for gas fires. But yet, up to this point in time, what else have we had to deal with those types of fires? We go in and we look at another video that shows a scene where you have a smoking area at a facility, supposedly a safe smoking area. And if you watch, again, I'm going to back it up here a little bit, you'll see that the flames come from the bottom right. It's not caused by the smoking or the smokers that are there in that supposedly protected area or that safe area. And you'll see how those flames come in. What do we use or what do we have that is able to suppress or stop flammable vapors from being able to ignite and start these explosions and these fires? And these are all things that, hopefully we can sit there and we can look at in trying to provide better fire protection using deluge systems or VEEP systems that are covered in the standard as I continue on and we talk about. So times, as we say, they are changing. We're getting into materials that are basically burning hotter and faster. And when they do burn, they're releasing toxic gases, carcinogens and toxins. And we're trying to find out ways to be able to deal with these and being able to extinguish them safely without having the impact that current technology has on the environment, as far as the PFOS and the PFOAs, those forever chemicals, those fluorinated ingredients. As another example, when we talk about, fire loads changing, let's look at, as an example, parking garages. Here we're sitting there and we're taking old parking structures and we're putting in charging stations for electric vehicles. And, I go to some of these places and I notice that these charging stations are on the lowest floors, the very ground level. We're giving people that drive these electric vehicles, the best parking places. We want to encourage people to drive and change over. So we're putting them on the lower floors, and it's like, we sit there, we watch these batteries and how these cars and how violently some of them can burn and the way they respond and react. And we're putting on some of the lowest floors of these parking garages. And when I look around and I take pictures of these parking structures, I don't see any added fire protection being added or being put in place. We're putting the charging stations in, but we're not doing anything else to help with the fire load that's being increasing in these structures. We sit there and start looking at other areas as far as hot work and some of the areas of plants and facilities, because we're using, combustible flammable metals, class D metals, because it's lighter weight and it's strong. And when we sit there and start welding at some of the incidents that we can have that occur, and we know if we use plain water in these types of instances and these types of suppression systems, we're only creating another problem, because if there is a fire and there are class D metals that are present, we can just end up with these huge explosions and molten steel flying throughout the facility. We look at, again, going back to the first, petrochemical, oil and gas facilities. We saw the vapors that caught on fire and basically endangered those employees that were supposed to be in a safe area. And again, by looking at some new technology, the encapsulator agent we're going to be talking about, we can see and hopefully understand how an agent, a new agent, and I shouldn't say new because it's been around since 1997, but how an agent that is environmentally friendly, is fluorine free, can be very effective at extinguishing these types of things. Look at aviation and the aerospace. We're getting more and more involved in trying to get man back to the moon, to be able to possibly visit Mars or do other things. And so we're looking at all the different aspects of trying to build lithium-ion batteries and things that are going to help sustain people when they go on these long missions. So as we sit there and we look, we're going to get in and talk about with this video a little bit about your encapsulator agents, because as I said earlier, in the NFPA 11 standard, which states foam is not suitable for three-dimensional fires, we're seeing examples. The first one was a distillation column. Here's an example of a well blow-off, a three-dimensional fire. We're doing it with one hand line. Okay, so let's think about it. Now, if we had a large and we had a deluge system, or we had a fire suppression system, the effect that we could have, okay, especially with being able to prevent that explosion or fire that occurred earlier on. Here's a mock-up of a jet engine cowling. How many times, if you go on YouTube and you do a search for engine fire at O'Hare Airport, you're going to see about 9 crash fire rescue trucks around one aircraft with an engine fire. And they're using all the foam and Purple K trying to extinguish a single engine on a plane. Here you have, again, that manifold that we saw that burned down 11 of 15 tanks. Okay, here again, a single hand line using a 3% solution of F500 and the effectiveness it's having at being able to extinguish a gas fire. That gas, those vapors that, again, I keep bringing it up, those employees that were endangered. And here we have the F500 being able to have an effect on an above ground storage tank. That valve, many times when I would go to trainings and dealing with valve fires, there were 2 hand lines flowing water, or water and foam, intersecting, crossing. Okay, and then you would sit there and you would use those to push the flames away while you reached in and you turned the valve off, or you tried to stop that leak. And there you just saw one hand line extinguishing the fire, cooling that valve so that now you can extinguish, or you can shut that supply off. The next video I want to show comes to us from Panama, and it's at a tire recycling plant. As I go through this, I'm gonna kind of stop it as I go along, because there's points that I want to make as we show this. And I'm glad that this was done because it kind of highlights the effectiveness of the F500 extinguishing some of these large fires. And this is going to talk about, 90 gallons of the F500 concentrate that was donated for the extinguishment of this fire. And we're seeing that they're batch mixing it. So, it's getting into the water stream. And once they pour it into the tank, it's going to mix instantaneously. And we're going to see a comparison because, many times I'll have people ask me about the cost of the encapsulator F500. And when we sit there and start looking at the cost, let's look at the savings. Let's not look at the cost. Let's take a look. And this is a really, really good example of what we can do when we start introducing new technology to the water and being able to deal with these high hazards. And when this facility had a fire previous, they had the fire department on scene using plain water for 42 hours. When they used a 1% solution, and this is showing 90 gallons that was donated, but we're going to see here, it was 1% solution and they used 2 hours. So now let's think about how much of a difference that is, 40 hours. So when we sit there, we start looking at that and we start taking into account, okay, the difference, 420 hours versus 10 hours. Okay, it was 2 fire trucks versus 1. How much diesel for those fire trucks was saved? Let's look at the black smoke. Okay, it's gone. So when we sit there and we see that black smoke is gone, what in many cases has to take place downwind? We're affecting the community. Okay, not only that, but how about the firefighters and others that are exposed to all the carcinogens and toxins from that black smoke as it's being released. Okay, if you're able to take it instead of 420 or 42 hours down to 2 hours, what kind of an effect is that going to have on the community in general? They probably won't even know there's ever a fire at the facility. So as we continue on, we'll see here, the 10 firefighters versus 1 or versus the 2 firefighters. So we had a difference. And I'm not trying to say that we have a huge, or we're trying to reduce the firefighters, but we'll see again, the black smoke, how it's turning white, and that's not steam. When we sit here, again, we look at the difference in plain water and the 1% solution of F500, the 2 hours. The thing that I want to point out here is because while we keep showing that number, of 90 gallons of concentrate, what I want to point out is right here. Okay, 42,000 gallons of plain water were used. But at 1%, we only used 3,000 gallons of water, of F500 solution. So if we do the math, we really didn't use 90 gallons of the concentrate. Because we only used 33,000 gallons of water, we only used 30 gallons of concentrate to make that 3,000 gallons out of 1% solution. So there are 60 gallons of that concentrate that weren't used. So when we sit there and start looking at the cost, don't think you need 90 gallons. You only need 30 gallons. So there's, again, I want to highlight that because, many people are concerned about the cost, but it shows the effectiveness. When you start getting the F500 into the water, the ability of this to be able to cool, to extinguish, and basically improve conditions, not only for the firefighters, but also the community. Okay, being able to fight those fires, being able to cool, to have an effect, reduce the carcinogens and the toxins that are going downwind. And as you see, all these pictures of in the video where they're fighting and spraying it, where's the black smoke? It's gone. It's gone. So the ability of this to cool and to reduce those and get ready to have an effect on extinguishing these fires is huge. We get into the NFPA 18A. Okay, this is the NFPA standard, and it's a standard on water additives for fire control and that word vapor mitigation. And I throw out there, what other standard are you aware of NFPA has that will work on flammable or combustible vapors to control a fire? I don't know of one, even with 27 plus years in the fire service. We sit there, we look at what and how this works. When we talk about, powders and gels, inerting gases, we talk about foams, all the agents that we're familiar with. When we get into the NFPA 18A, we find that we're talking about spherical micelles. That's the basic building block. And as we continue on into the standard and we go deeper in, there's section 7.7, which is the spherical micelle stability test, okay, which tests the ability of these spherical micelles to encapsulate flammable combustible liquids or vapors and hold them even in the presence of high heat. Excuse me. So in here, in the standard, it talks about, the innovative technology. It's non-corrosive, it's fluorine-free, it's been tested. It's been tested by an EPA-approved lab for 25 different fluorinated ingredients, and the results are there is 0 detectable amounts of fluorine in the product. It is a multi-class CULUS and NFPA compliant fire protection suppression agent, as well as we talked about, that combustible flammable vapor and liquid spill control. The product is on the US EPA's National Contingency Plan as a surface washing agent. So when we start to deal with some spills and we start to have some instances where, this product is used, your cleanup and your mitigation is Mother Nature. Let it evaporate. Once that flammable combustible liquid's been encapsulated, it is not going to light. As long as you're monitoring for LEL and that LEL is reading 0 and we've encapsulated it, that solution now can evaporate away, and through the evaporation process, it will never reach a flammable range again. And the EPA has approved this product for use in pipeline spills and incidences, and some of them have been near nature preserves, sensitive areas. It's been approved because we're not adding organisms, we're not adding things to the environment that would be harmful. As I said, it's biodegradable. So because of that, when we are used and we encapsulate that fuel that might be in the ground, what we're doing is we're actually helping to break down the petroleum so that it gives more surface area for the naturally occurring organisms to help break it down and digest it and help mitigate those types of incidents and spills in a shorter period of time. Now, these are all areas so that when we sit there and we start looking at, petroleum industry or areas where, we may be putting these deluge systems in or fire protection systems in, the water runoff and the hazards that might be caused by, it's not going to be the same as it would be when we're using other products. So to give you an idea of these spherical micelles and what they are, let's look at what the basic building block. The basic building block of a spherical micelle starts with our molecule. Our molecule has a polar head that loves water, dissolves in water, wants to be in water, and a non-polar tail which fears water and will do everything it can to get out of the water. So when we sit there and we introduce this either through an eductor, batch mixing, as you saw with that truck in the tire video, when it gets introduced into the water, it instantly and automatically orients into these spherical micelles. And as now they travel through the water stream and either come out of a sprinkler head, a deluge, or a nozzle, those spherical micelles that are closest to the surface of that water droplet, they break apart. And we now have those tails, okay, on the surface. So I've now put a skin on the surface of each and every water droplet. Yet inside of each and every water droplet, there's still millions and millions of spherical micelles. And that's where our encapsulation takes place. Okay, so when we're encapsulating those flammable vapors, those flammable liquids, that's inside of the water droplet. So through the evaporation process, we don't get enough evaporating at one time where we create an explosive atmosphere again. The other characteristics when we create these spherical micelles is we change the mechanism of cooling. With water, we're creating steam, and we're only using about 3 to 5% of a water droplet to be able to cool and extinguish a fire. When we sit there and we introduce the encapsulator agent into the water stream, we are changing that mechanism of cooling from steam to thermal conveyance. And what is thermal conveyance? Well, let's imagine those tails on this water droplet like a heat sink. Okay, those tails will take the heat and they drive the heat inside of the water droplet. Those spherical micelles that are inside, they are going to rapidly absorb the heat and then slowly release the heat into the water that surrounds them. Through the process, there's no steam. Steam burns are gone. I can take temperatures that are in excess of 12 and 1300 degrees. I can take that steel tank that holds the heat, okay, and as a reignition source when a blanket breaks down or current technology fails and we have a reignition, I can take those temperatures of the steel and drop those temperatures down to 100, 120 degrees in seconds. I'm eliminating that reignition source. It's a huge difference in how we're able to control many of the high hazard fires that we deal with.
Encapsulator technology.
We look at some of the mechanics, some of the properties, because there is another, let's look at the difference between just a normal wetting agent that's covered under NFPA 18A and NFPA 18A, your encapsulator technology. We've talked about the ability of this to encapsulate those flammable gases, flammable vapors, rendering them non-flammable, reducing their hazard. I just talked about that heat reduction, that source of reignition, being able to cool it so that once the fire's out, you don't have that reignition source. We mentioned that interruption of the free radical, that black smoke in the tires going down when affecting the community, how we were able to have an effect, reducing it, okay, and the carcinogens and the toxins that are being released, being exposed, not only the firefighters, but everybody. And let's think back again, let's talk about the amount of water that was used. How about all the water runoff and the contaminants and the hazards that are present with that? And then the surface tension reduction so that it can better penetrate and get into areas where plain water can't. Yeah, we go into the NFPA, which is wetting agents. It's not going to encapsulate. It's not going to do anything to reduce the flammable hazard. It's going to do very little, excuse me, to reduce the heat. And it's going to do nothing as far as that black smoke and the black soot, as far as reducing the hazards and the carcinogens and toxins. Yes, it does reduce the surface tension of the water so it can better penetrate, but that's all it does. So it's very important that we don't get these two standards confused. There is a huge difference between agents that fall under NFPA 18 and those that fall under NFPA 18A. So when we look at many of the groups, the agencies that have tested, the companies that have tested, your encapsulator agent, the F500, one of the main reasons why they've switched over is because it's an all hazards extinguishing agent. Instead of having, to put multiple fire extinguishers up on a wall and train your employees, hey, you use this one for Class D metals, and you use this one for electrical, and you use this one for, a lithium. It's one extinguisher that can deal with all the hazards. It makes the training of the employees and makes the ability of having an effective agent to be able to deal with these fires much more effective. And I'm going to sit there and, get off this for just 1 minute. And let's talk about, look around, our office building. Let's again, look at those parking structures. Let's look at our manufacturing facilities and think, what is the fire extinguisher that's required by code? In many cases, they're dry powder. But yet, how many times do we hear in New York a lithium-ion battery scooter in a building burns and has an effect that can kill, injure, and burn buildings down. And that's because we don't have an extinguisher that can deal with them. And we're dealing with the same thing when we start looking at our manufacturing facilities, when we're looking at our distribution centers and other areas where we have sprinkler systems. Okay, the fire loads have changed. And when these systems were first introduced into these buildings, they were based upon minimum codes and standards. The systems were hopefully designed so that they would control a fire until the fire department could arrive and be able to extinguish the fire. But now, if we just take and we start looking at introducing a water-driven propulsion, which I'll get into and discuss a little bit more, but we start introducing F500 technology into these fire protection systems, we can improve them from a point where they were designed to control the fire till the fire department arrived to the fire's out. And the fire department is just checking to make sure everything is safe and everything is extinguished. We can have a huge impact by adding a little bit of encapsulator agent into these systems. And we learn about how we can have a huge impact on being able to mitigate these hazards using less water, eliminate the flammability, prevent that incident that occurred that caused those employees to become burned or injured because of the vapors that were on the ground that were undetectable. Okay, that burn back resistance that we are familiar with. If you're seeing some videos, once excuse me, once F500 has been used to treat, let's say, a Class A material, or I've even seen it with some Class D materials. Yes, it will burn. We're not going to make it so that it will never burn again, but it's going to take more heat. I've seen some pallets that have been treated with the encapsulator agent go back weeks later and pour some diesel and some gas onto these pallets, light them off, and the pallets burn. I shouldn't say the pallets don't burn. The fuel burns, it's gone. The pallets are still there. They don't burn. So that burn back resistance is a huge property that is beneficial when using this product. And as it shows here, a simplified cleanup. In many cases, just let it evaporate. There's no special mitigation that takes place. We look at the mechanics and how it works. You know, we've talked about, you know, those spherical micelles and how they work and being able to encapsulate not only the liquids, but the vapors. And it's inside of that chemical cocoon, inside of the water droplet that we refer to as a chemical cocoon. So once it's inside of that water droplet, it doesn't get released. I mean, unlike a foam or other products where, you know, you have to be worried about, you know, walking through it and disturbing a blanket or having some type of effect. With this, once it's encapsulated into the water droplet, you can walk across it. You know, it's not going to have an effect. It's going to evaporate and it will be mitigated thanks to Mother Nature. We have a video. This is one where I just talked about that wood being treated with pallets. We've got a stack of pallets here on the left that were pre-treated with the F500. We've got some that have been treated with some diesel fuel. So we're going to light them up here and we're going to see, as I speed this up, how we have some flame impingement, some high heat. That's right next to these pallets. We're seeing here in excess of 1100 degrees. The fire continues to grow. We will see that these pallets next to this are affected. And again, let me go back to that warehouse. Let me go back to a manufacturing facility where you're using F500 into your fire suppression system. If you have something that's burning and the system goes off and it starts spraying materials or products that aren't yet affected by the fire, what type of effect do you think that's going to have in being able to help control and extinguish that fire? So we can take systems that were once designed as minimal standard and basically, you know, create them and improve them to a standard that's just, I mean, a huge difference. That's not only made for today's fire loads, but future fire loads. I mean, we could look and have a huge impact on some of these standards. So as you can see, we're going to let this burn here. Let me back it up here just a little bit more. Sorry about that. But again, so we've got, again, still about 1120 degrees. We're going to get ready here in just a second to extinguish this fire with the TKO nozzle. It's a little 20 gallon per minute nozzle. And most times when we did this, it was 1% that we would use. So we'll see just how quickly we are able to extinguish. Again, that's a water mist coming off of there. It's not steam. So if you just stick your hand into that, it's been described as being no hotter than a shower. What was once 1100 degrees, you'll see here now is 122 degrees. And it's cooled down. You'll see people walking up to it, bare hand, now touching, those wood pallets that were once just seconds ago burning at 1200 degrees. So as we continue on in this video, we're going to see how what we're do is once we've extinguished these batteries, it allows some of those people to kind of see how much it's cool. We'll take a torch. We start putting the torch onto those pallets. You'll see those will start glowing cherry red. We'll get some flame, but the minute we pull the torch away, it self-extinguishes. We then go over to the pallets that were pre-treated and had the flame impinging on it. And we'll go to these pallets and we'll see when we put the torch onto those, we will have, some charring that takes place. We'll have some flames that might start to grow while the torch is there. But again, you'll see as they pull the torch away, the flames will self-extinguish. So again, we think about this in applications of warehouses and distribution centers or other areas where, we have Class A materials or, materials that can readily burn. That effect that F500 can have once it's been sprayed on those materials to help prevent the fire from spreading throughout a facility, throughout a structure, making it more easily extinguished. So that rapid heat reduction, as we saw, that improved knockdown capabilities. Instead of, as I said, with water, only using 3 to 5% of a water droplet to cool and extinguish, we've now made that water droplet about 95% effective at cooling and extinguishing. So we're making water more effective at being able to cool and extinguish. And just like you saw with the comparison between water with the tires and F500, the difference in the amount of water that was needed, it offers a huge difference. And in doing so, the effect as far as the environment, the runoff, I've gone to structures and, seen the hundreds of thousands of gallons of water used on some of these facilities. And where does the water go? It goes off into the environment. What goes with it? Whatever's burning, and whatever materials are part of that fire. And it can have a huge effect, a lasting effect on the environment, as we're aware of now, as we become more and more aware of how much of an impact some of these agents and some of these chemicals are having. So if we're able to extinguish these fires using much less water, it will have a huge, huge impact on the effects to the environment. So we saw, and I mentioned, how those droplets with the skin on the surface, those tails act like a heat sink. They drive the heat inside and it absorb that heat without causing or creating steam, that scalding steam that we get with water. We eliminate those steam burns. But again, let's think about that black smoke. How about if I'm able to have an effect at encapsulating that black smoke, I improve visibility. So then if we're in that warehouse situation where normally firefighters have to cut holes in the roof, okay, to let that black smoke and that heat out so that they can see. Okay, now we've got something that's in the sprinkler system, the suppression system, that's going to not only start to extinguish the fire, but it's going to have an effect in improving the visibility so the firefighters can get in there and find and be able to extinguish. Lithium-ion batteries, the hazards, that we keep hearing about, and the growing hazard. Because we're trying to cut the cord. We want, things that were once plugged into the wall that needed electricity now be wireless. And lithium-ion batteries seem to be the answer because they hold a lot of energy. We'll see here with this particular fire, with the thermal imaging, the effect that F500 has on being able to rapidly cool and extinguish this battery. The other thing is again, we hear about all the hazards that these batteries bring. The HF gas, the corrosive and toxic electrolytes, the flammability of the electrolytes. Okay, well, with water, hours, days, weeks later, we have reignitions because of the stranded energy. And it's not only because of the stranded energy, but it's because of the flammable electrolytes. You figure if you still have a flammable liquid that's present in the battery, and I have some stranded energy that's going to cause a spark, I've got everything I need for a reignition, hours, days, or weeks later. But yet we just saw how the encapsulator agent's able to encapsulate that flammable liquid. Well, it does the same with the electrolyte. It encapsulates the electrolyte. It gets rid of that flammable hazard, and it reduces the chances for those reignitions. We look at the toxins, and I mentioned it throughout, and I'll continue. It's important because we're trying to improve our environment. We're trying to reduce our exposure to carcinogens and toxins. And here we'll see from testing that's been done how this agent into the water stream can improve those conditions. We saw in the videos with the tires again, the improved air quality. It does the same thing inside of a structure. If we're sitting there, we're starting to use this, we can improve the visibility. So again, while I mentioned the firefighters, how about employees? If you have a large facility, and I mean, some of these warehouses today are just mammoth. A person could easily become disoriented when a fire occurs because of the black smoke. And if we're able to put something into the water now that can not only fight the fire, but reduce the smoke and improve visibility, what do you think that's going to do for those employees that might be disoriented as far as being able to escape or be able to be found by the fire departments doing a search and rescue and saved? Okay, it can make a huge difference in life safety, not only in being able to extinguish the fire, but life safety for all the employees. Let's look at how it works by, the droplets being able to create that barrier, stopping that chemical chain reaction, reducing the toxicity of the smoke. When we sit there, we look at it, we get deeper into the encapsulator agents and how it works. We'll see that, one of the things that these micelles are able to do are they're able to also encapsulate hydrogen gas. Well, when we sit there, we start looking and we get into our chemistry, we'll see that many things have a hydrogen molecule. So if the encapsulator agent, as it's going through the air and, this black smoke is getting ready to form, if the encapsulator agent can basically encapsulate that hydrogen and stop it from becoming bonded with, whatever else is burning to create these carcinogens and the toxins and the black smoke, I believe that's where that ability for this to reduce those carcinogens and the toxin comes in. So as we sit there and we start looking, some videos here, here's a great example that shows the effectiveness. In many cases, I'll see people with a tire fire like this, and they're going to pull a hand line, an inch and 3/4, inch and a half hand line, and fight this fire. We're here, we're seeing a 2.5 gallon water extinguisher with F500, 3%. You saw how quickly the black smoke turned white. The cooling ability of the product. And when he gets done, he probably hasn't even used but half of the extinguisher to be able to extinguish. And I always stress to the fire department, we need to do our overhaul. We need to make sure that we've been able to cool and extinguish, and that we have all the area cooled off. As I said earlier, we want to get those temperatures down below that auto ignition temperature so we don't have that reignition. I've mentioned the benefits as far as the ecology, how it's eco-friendly, the cleanup cost. And I can cite multiple examples as far as the cleanup cost. And I will, for one, I'll go back to that slide just so I can talk about the one incident that I'm aware of that happened in Topeka at one of the regional airports there. There was an incident that occurred. There was a person that was going to fill an underground storage tank at an airport with jet fuel. He connected to the pump house to fill this underground storage tank, and he connected to the wrong tank. He began to offload his truck. Jet fuel started coming out of the vent pipes. He called his office. He called to find out what he should do, and they told him to run. And he did just that, leaving the truck, continuing to flow jet fuel and trying to fill an already full tank. So it's estimated somewhere in the area of 3,000 to 4,000 gallons of jet fuel was overflowed. That went onto the roof of this pump house, spread out onto the ground, onto the tarmac, and less than 300 yards away from where this was taking place was a control tower. Crash Fire Rescue responded. It was a hot, somewhat windy day. So they had to keep reapplying the foam every 6 to 7 minutes, I'm told, trying to keep a blanket down and suppress the vapors. Well, thanks to some training with the local fire department, they were aware that a utility company had a trailer. The trailer held 500 gallons of concentrate, and this utility company made it available to the fire departments in the event of an emergency to help them out. So the fire department called for this trailer of F500. They used, I'm told, about 230 gallons of the concentrate, a 3% solution. They washed down all the areas that were affected, the tarmac, the roof of the pump house, the ground around the pump house, all the areas that were affected. And they gave it a 20-minute period of time before they went in with LEL monitors and did a recon, checked it out. When they were in there and they were looking and testing with their monitors, they found 0 LEL. So the incident commander deemed that scene safe for the night and let everybody leave the scene for the night. The following morning, they had the state environmental department, they had the EPA, they had all the cleanup contractor, all on scene so that they could dig up and mitigate this scene. When they got there, they got their monitors out and they started doing their testing. Same thing as the day before, 0 LEL. So they selected a spot and they said, well, let's dig here. We know this area was affected with the jet fuel. So they started digging area up, started monitoring, continued monitoring. And the whole time they were digging and monitoring, they got 0 LEL. So they kind of scratched their head and moved to another area. Well, let's try digging here. We know this area was affected. So they dug in another location. Same thing, 0 LEL. The cleanup contractor was there for 45 minutes. EPA, the state environmental department, deemed that area mitigated and safe. There's your cleanup cost. How much do you think it did versus having to spend hours or days digging up, tons of soil, having it hauled off to a hazardous waste site, bringing in new soil, okay, and all the time that would be spent doing that. Here, the use of the encapsulator agent, the scene was mitigated. So we look at, the ability of this to mitigate those scenes and encapsulate those flammable vapors and mitigate them using a VEEP system, which we call the Vapor Encapsulation Explosion Prevention System, also covered in NFPA 18A. How it's able to have an effect and prevent those fires and explosions from happening. I mentioned that reduction in those temperatures, excess of 1200 degrees down to 120 degrees, and even saw with the pallets. mean, burning at 1100 degrees, a quick application of the F500, and people are going and putting their hand on top of them. And even the temperature sensor that they had was showing the temperatures were down about 112 degrees. We talk about the ability of it to absorb those calories of heat, the kilocalories, you know, thousands and thousands of kilocalories of heat, more so than just plain water. That burn back resistance, long-term stable burn back resistance, as a matter of fact, I will add, because I've heard people, you know, talking about months going back trying to light pallets or wood materials or materials that have been pre-treated with F500, and they won't burn again. And I'm not going to say they won't. I shouldn't say, because they will. We just have to generate enough heat again to get them to burn, more so than a non-treated material would take. Okay, that rapid energy absorption, you know, the reduction in carcinogens, improved visibilities, and best of all, environmentally friendly, biodegradable, non-corrosive, and fluorine-free. So let's look at the lithium-ion battery hazards. I did mention them earlier when we talked about those parking structures. Huge problem. And as you know, I've talked about with those facilities, those distribution centers, the warehouses, how about with the airlines? We are constantly hearing about ships, how all these different areas where these batteries are being transported, being stored, being used. You know, we're hearing about incidences where these batteries will fail, catch on fire, go into thermal runaway, and cause huge amounts of damage. And it appears for some reason why, you know, they want to sit there and they want to say water, copious amounts of water seems to be the answer that people are pushing. But yet, if we go into and we start looking at testing that's been done around the world with the encapsulator agent, we're going to see huge success stories. Okay, and here's an example. This is one that was done by TU Clausthal. This is a large battery that was found in a utility vehicle. This was put into a Connex box. They've got two pendant style sprinkler heads, and they've let this battery go into thermal runaway, thermal propagation, let it burn. They want to see how effective a fire sprinkler system would be on being able to extinguish a lithium-ion battery fire. So I'm going to go ahead and speed this up just a little bit, because, you know, we've got to let these batteries burn until they build up enough heat, okay, to cause those sprinkler heads to activate. I'll continue on here just a little bit more. And one of the things I want to mention is that, you know, we got to kind of pay attention and watch, because this is one of those videos where, you know, if you kind of blink or you turn your head at just the wrong time, you're going to miss it. So we see, you know, these temperatures are going to continue to go up. The system's activated, and woof, within just seconds, the flames are gone. The fire is extinguished. Okay, the system continues to run though, because we want to make certain that we're getting enough of the agent in to encapsulate those electrolytes. Okay, so that we don't have to worry about that reignition. We want to make sure that, again, we're getting that agent in and cooling those batteries down below that reignition, and we're able to stop that thermal runaway that's taking place. So the system continued to run, even though the visible flames were gone. We want to make certain that we get enough in there to encapsulate and to rapidly cool and get those cells out of or below temperatures where thermal runaway is stopped. So when we look at these types of fires again too, and all the testing that's been done with foams, powders, gels, inerting gases, okay, those are all very ineffective because they do very little to be able to remove the heat. Where we saw how with the encapsulator agent, we can take those temperatures that are in excess of 1,1300 degrees down to 100 degrees in seconds. We've seen how in videos with the distillation columns and the well blow off and the jet engine cooling, those three-dimensional fires, we see how effective the encapsulator agent is being able to work on those three-dimensional fires as well. And we talk about that burn back resistance. The explosivity of the gases. Testing shows that when lithium-ion batteries burn, you know, one of the other properties, while we hear about the methane, the CO, the CO2, one of the things that we really haven't heard about is the amount of hydrogen that's being released when these batteries burn. And if we think back to an incident that occurred in Surprise, Arizona with a battery energy storage system, the firefighters went, they responded to a system that had failed. They got on scene, and the fire department and the firefighters did what they should. They took their time. They got representatives from the company that owned that energy storage system on scene. They talked with the people that were, there with them and learned about the system as best they could. These systems had fire protection systems, inerting gas systems in them. And well, after a period of time and doing some thermal imaging to see what the temperatures were best they could, they thought the only way that they were going to be able to do and learn more about what's taking place inside was to open it up. And when they did, there was a huge explosion, blowing firefighters 50, 60 feet through a cyclone fence, injuring some. 2, I believe, are still off duty. Hydrogen gas. We had an explosive atmosphere. The system that was in there did little to nothing to be able to cool. So when the doors were open, air was introduced into the tank. We hit that proper air fuel mixture. We had all this hydrogen. We had the heat. We had a huge explosion, okay, which then caused these injuries to the firefighters. We sit there, we start looking at the ability of the F500 to encapsulate. One of the things it's able to do is it's able to encapsulate the hydrogen gas. The other, the smoke that comes off the batteries, the hydrofluoric, okay, the carbon monoxide, the carbon dioxide. F500 is able to encapsulate and reduce the toxicity, reduce the HF gas, greatly reduce. And like I say, we've got reports showing the amount of reduction that is F500 is able to create or cause when it's used on these types of batteries.
Lithium-ion battery test.
This is a lithium-ion battery test, as it was saying. They're again overcharging this battery, causing this battery to go into thermal runaway, thermal propagation. It's kind of interesting because it just shows just how violently. Look at how much of how much smoke is being released, the HF gas, the other toxins. So if we can now start to have a solution that can spray down on top of that battery, and it can start to encapsulate all those toxins, preventing them from going downwind. And I mean, how many times are we hearing about these battery energy storage systems that are catching on fire and burning and causing downwind evacuations of a community for half a mile or whatever it might be? Okay, we started looking at this fire. Batteries are burning, the black smoke being released. We can see, at times when, another battery or another part of the battery starts to fail, just that violent, explosive fire that's generated. So now we get into this. We speed up here just a little bit too much. We start looking at the application of the F500, just like we saw with the previous battery, how rapidly the flames are gone. But yet we want to continuously flow. Now we want to start using our thermal imaging camera. We want to monitor. We want to watch and make sure that we are cooling that battery down to a point where we have stopped the thermal runaway, that we continually have an effect on to cool the batteries and encapsulate. We want to make certain that we hit the right formula. We're able to encapsulate all the electrolyte. We want to make certain that that flammable source for a possible reignition is gone. So we're able to have a huge impact on being able to extinguish and stop the thermal runaway and extinguish these batteries. And if we go and we start looking, and I like this slide because while many people talk and tell about, water is the only solution, and there's copious amounts of water, and we hear, 30,000 gallons of water on a car fire, 1.5 million, 2 million gallons of water on a battery energy storage system. Let's look to the Dutch. If there's an NEN NTA 8133 standard that was created by the Dutch, and they did it because they were trying to find a solution for lithium-ion batteries. They wanted to see if there was something that they could find that could work in a fire extinguisher to deal with fire in basically buildings or scooters or small applications. So what they did is they created this test protocol, this test standard, and a listing and markings for an extinguisher, where if you pass this test, you can get an extinguisher marked and listing for it to be able to be used on lithium-ion batteries. And this test goes up to a 600 watt-hour battery. The test is we take 6 batteries, 100 watt-hour batteries. We start them on fire. When they go into thermal runaway, extinguishing takes place, and the batteries need to be extinguished. And once they're extinguished, they have to set for 20 minutes with no reignition. Now, at the end of the 20 minutes with no reignition, they then will go and check for an electrical charge on the batteries. They want to make certain that the batteries didn't completely burn up, that you did extinguish them, and that didn't burn themselves out. So we come in and we do a charge and make sure that batteries have a charge on them. There's 3 tests. You have to pass 2 of the 3 tests in order to get the listing. And F500 has been able to pass this and get a listing based on its passing of the first two tests it was done with. Water can't pass the test. But yet you still have the experts telling us copious amounts of water. We look at some of the testing. We saw that video that I just showed with the Connex box. You know, we've got testing that goes up to 3,500 watt hours, you know, huge batteries. When we sit there, we start looking at the ability of the standard of the agent. And when we go into, again, NFPA 18A, and we go into Annex 4.3 of the standard, we're going to see a list of all the different, or I shouldn't say all, because the list is continuing to grow. But we're going to see a list of many of the facilities, TU Clausthal, Fraunhofer, Kiewa, Johnson Controls. I mean, the list goes on of all the different groups that have tested F500 on lithium-ion batteries, starting back in 2008, which is Bosch, to present. I mean, what other agents have been tested that thoroughly and that in depth on lithium-ion batteries? And now when we sit there, we start looking, you know, all of these groups that have tested are using. You know, most recently, NIOSH, you know, here in the United States did testing. And they, from their testing, in their report, in their conclusion, show that introducing F500 into the water stream was able to better extinguish these fires. But yet we're still, for some reason, stuck on water. And I've talked about how it can have a huge impact in all the different applications in our warehouses, our homes, our buildings, our offices, our schools. Okay, we look at, you know, the ability of it to mitigate the rapid heat reduction. Again, the differences between the agents that are out there versus the encapsulator agents. You know, foams, NFPA 11, doesn't work on a 3-dimensional flowing liquid fuel fire or gas fire. Encapsulator agent does. Poor heat reduction. The foam blanket breaks down. When it does, the heat, the fuel, oxygen is then present. You have reignition. Okay, we have to worry about the toxins. Okay, the PFAS. Inert gases, while they're great possibly for computer centers, for data centers, switch rooms, electric panels, they, again, are very ineffective on many of the applications, especially lithium-ion batteries. They don't do anything or very little to reduce the heat, and nothing to reduce the toxins. And then that water, you know, again, looking at the amount of water that's used, you know, thousands of gallons of water, for instance, on that tire fire versus 3,000 gallons. How much difference in water runoff? How much difference in environmental impact? Not only the black smoke, but I mean, let's look at, and especially in some of these areas that are experiencing drought conditions. You know, do we really have thousands of gallons or millions of gallons of water that we can use on just one incident? So let's look at some of the ways we get this product into the systems. You know, probably one of the most common up to now has been the bladder tank systems. These are systems where you can either get the, you know, the vertical tanks, or we get into the horizontal tanks. they require some, electricity, some valving, might be a little bit less expensive up front, but as far as the maintenance, we're worried about water hammers, damage to the bladders. These are, systems that can be easily affected, and but yet they're economical, and many places have them. Now, if they're currently using, some other product in them and they want to be changed because many people want to find a way to get rid of their fluorinated foams, yep, you can probably get it converted. You're going to have to do some changes to the tank, and one of the things will be the bladder. The bladder has to be removed and replaced. Some other parts of it will have to be replaced as well. More than happy, get a hold of us at HCT. We can help you out with that. But one of the other more effective and efficient ways is water-driven proportioners. And I'm going to tell you, when you sit there, you look at those bladder tanks, those bladder tanks are good, but, as I said, with, the problems of the bladders being damaged for different reasons. The other thing is when we have a system that has a riser and it's dealing with, let's say, 8 or 10 sprinkler heads, if the system is designed to flow 3%, it might be at 3% if half of those sprinkler heads go off. So now if we only have a third of them go off, we're not flowing that 3% because we're not getting enough water going through the system. Okay, we have to hit that half. And if we have more than half going off, again, it's going to affect our percentage. We're not going to get what we need. When we sit there, we start looking at these water-driven proportioners. These water-driven proportioners don't require any electricity. They work based on water flow. Think of it like the hamster wheel. The faster the water flows, the more it increases the speed of the pump, and it puts more of the concentrate into the water stream. It works over a wider range of flows. It might work from 200 gallons per minute up to 1,200 gallons a minute. So again, we start looking at 1 sprinkler head or 5 sprinkler heads. No matter how many are opening up, as long as it stays within that 250 to 1,250 or whatever the range might be for that particular water-driven proportioner, you're going to get that 3% or the 1% or whatever percentage you're looking for. You're going to get it throughout that whole flow range. As far as the maintenance, when you have to do your annual testing, okay, with those bladder tank systems, you have to get, a frac tank, or you have to get something there to catch that water runoff so that you can collect it and haul it off. Yet with the water-driven proportioner, you can basically run the system. You can take the concentrate and have it go back into a bucket and reclaim and be able to check the system without having waste, and being able to do your calculations on making certain that it's flowing at the correct percentages. Just to give you an idea of how these work, there's a real quick animation which shows, as the water goes through, the wheel turns, that concentrate then will get pumped from the concentrate tank, be it a IBC tote or another type of tank, and it gets introduced into the water stream. So it's much more effective. It's very easy, to integrate into systems. As we talked about, convenient to do your testing with zero waste, much more effective, requiring less maintenance and upkeep. It comes and is able to proportion in a wide range as far as the fixed rates and variable rates. It shows the dosing, viscosities when we sit there and start looking, and it pulls from a standalone atmospheric tank. So there's no extra pumps that are needed, no extra systems. Like I say, these are all running on water, so there's no electricity or other things that are needed. So when we sit there and we start working with fire protection engineers and trying to get these systems integrated into either new systems or existing systems, we've got some people in-house that can help with getting the equipment spec'd out and help you with the designs, so that we can make certain that we're getting the proper flows, the length of time, and we start having basically getting the right solutions for your particular hazards. And just some case histories. So here's one that's showing two 600-gallon bladder tanks that have the F500 used for titanium storage, that class D metal, where we don't want water, but yet we want to have some type of fire protection to protect our facility, protect our employees. Well, the solution was F500. So we've got systems. Con Edison using it for protecting transformers or being able to extinguish transformers. And, they've done testing up to 345 kilovolts. And we've got instances where, the F500 has been used to extinguish these transformers, requiring less water, having less of an impact on the environment. Where when other products have been used, we're looking at possibly millions and millions of dollars in cleanup costs. Where with F500 being used, okay, it's basically been able to stay within the diked area where these transformers are. Cleanup is minimal. Embraer, which makes airplanes, looking for fire protection for their warehouse, testing all these different types of extinguishing agents, high expansion foams, gels, powders, okay, and F500. And with the composite materials and the things that they were trying to protect, they found that the most effective agent was F500. So we've got F500 systems there down in Brazil with Embraer. General Motors building a new battery abuse lab, looking for a solution. Why make certain that, hey, within the GM Tech Center, they don't have a huge fire that burns their basically research center down. So after doing some testing with the F500, we are now protecting GM's battery abuse lab. Goodyear in Memphis, wanting to sit there and save money. They had a warehouse. In the warehouse at times, they would have so many tires that they, because of the limitations on the number of racks they could have within their building, had to rent additional warehouse space. They were trying to see if they couldn't go one rack higher so that they wouldn't have to keep running that additional space. Again, testing took place. Looked at F500, working with the authority having jurisdiction, the fire department. Okay, going through the testing. Based upon the testing and the ability of the F500 encapsulator agent to cool and be able to extinguish, they allowed, with the introduction of F500 into the fire protection system, they allowed Goodyear to go one rack higher on their storage. In Kuwait, here we have an example now. Let's get into those flammable vapors. Okay, LNG. Okay, two 2,700 gallon and two 2,100 gallon and two 1,400 bladder systems, all using F500 to protect their LNG plant. Okay, in Maryland. So they understand the ability of this to help reduce the hazards and allow, in the event of a leak or an event of an incident, the encapsulator agent to be able to encapsulate vapors while maybe emergency shutoffs or devices activate so that it stops. But they know by using the F500, they can have an effect in stopping those vapors and having an effect and reduce the chances for that explosion and fire. We go into Tesla, okay, Sparks, Nevada. We've got a number of systems that are protecting all the areas. And again, the water-driven proportioners, working to protect the areas where they make, charge, and put these batteries together. And we go here and we see the list of just all of the different areas and all the different companies that are using F500. And this is after testing, working with them, showing them the benefits that using F500 to protect their facilities brings. Doing coal dust in silos, conveyor belts, many applications. It's not just, the oil and gas industry, but, you can get into, these grain silos and all these different areas where people are looking for a solution to be able to deal with, dust collectors and many other applications. If they're looking for a solution, chances are F500 can help with these high hazard incidents and high hazard fire situations. So with that, I would like to let everybody know, please, take a moment, scan, let us know how we're doing, give us your feedback. If there are some things that you would like to see in future webinars, or we'd like to see something better that could be presented in, for instance, this one, please let us know how we're doing. Send us your feedback. And now with that, okay, well, thank you all for joining us today from wherever in the world you may be, and taking either your morning, your afternoon, or evening to join us. I know some have had to leave early for other meetings and so on and so forth, but I would just like to thank you all for coming. Hopefully that we've given you some information. Feel free to, if you have additional questions, contact us. Hernan has been recording this and we'll be sharing it with everybody that's attended, along with information on the presentation as far as reports and things that were covered. But again, thank you all. Have any questions, contact us. We're here to assist and help you with dealing with some of the high-end fires that you're looking for solutions for. Have a great day, evening, night, wherever you may be joining us, and I hope you join us again in a future webinar.